going to use this amazing theorem to help us find the derivative of inverse of functions without calculating the inverse of that function. So first of all, if you have a differentiable function and it has an inverse on an interval, remember that for the function to be 1 to 1, or it has an inverse, it must pass horizontal line test. Suppose x sub 0 is a point in that interval, and suppose the derivative is non-zero at that specific value. Then the inverse of the function is also differentiable at y sub 0 equals to f of x sub 0. And it's defined this way. The derivative of inverse at y sub 0, remember that for the inverse of the function, we switch the domain and range. The domain of the function is going to be the range of the inverse of the function, and the range of the function is going to be the domain of the inverse function. It's equal to 1 over the derivative of the function at x sub 0. Let's take a look at one example. In this example, question says, well, we have a function. This function is defined as square root of x plus x squared plus 1. This is a one-to-one function on positive real numbers along with 0. Well, it has an inverse. Question says, find the slope of the curve, which is the inverse of this function. So we're not going to calculate the inverse of the function. We're going to just apply the theorem and find the derivative of the inverse at that given value. Remember that the derivative of the inverse is equal to 1 over the derivative of the function at x sub 0. And remember that y sub 0 is equal to f of x sub 0. And take a look at this important point. Very good. So for the function itself, we have square root of x plus x squared plus 1. The derivative of square root of x is 1 over 2 times square root of x plus the derivative of x squared is 2x, and the derivative of 1 as a constant is 0. So basically, the derivative at 1, remember that this is the inverse function. This is basically your y, and this is basically your x. You switch these two. The derivative at 1 is equal to a half plus 2. So wherever you see x, you're going to plug in 1, and it's equal to 5 divided by 2. So the slope of the inverse function at 3 is equal to 1 over f prime at 1, which is 1 divided by 5 over 2, or 2 over 5.